Okay, now we have a hyperbola to do, and hyperbolas are exactly like an ellipse. In ellipse, you have four little vertices like that, but we could put a box around that. An ellipse, if we do the box thing, an ellipse is on the inside of the box, and a hyperbola is just on the outside of the box. So they work very much the same. We could do an ellipse with the box, just like we do the hyperbola with the box, but usually we don't. So it's almost all the exact same information, or the exact same process. So when I look at my hyperbola, see when you compare a hyperbola, that looks like an ellipse, only one of them is minus, where in the ellipse they're both positive. See here they're both real, so they both count. Here one of them is not real, so one of them doesn't count. So let's see if we can't figure something out. Okay, it looks like we have some really weird vertices here, but here the vertices look like a mess, but the focus points are reasonably nice. So let me get a sketch of this. Okay, 6, -1. 1 to 6, -1, so let's just call that 6, -1 right there. And then -24, -1, so someplace way over here. -24, -1. So those are the focus points. Okay, that means the ellipse, that means the focus points are always on the inside of our shape. So that means it's going to be going something like this. It's a sideways one. So now the vertices. How about we get the center before we go to the vertices, because the center is going to be halfway between those. Okay, so our center, -24 plus 6, cut in half, and then -1 plus -1 cut in half. So -20, so that's -18 cut in half, so the center is at -9, -1. So somewhere right about here is our center, -9, -1. Okay, see already we have a lot of it. We can get some of the equation already. We have x. Now, I know that it's going to go this way. So the vertex is going to be right here somewhere. So it's going to go like this. See, the x going sideways is the real one. So going sideways is the positive one. So I know that the x plus 9 all squared is the positive one, and then the imaginary one is the y one up here that does not have the vertex. So it's y plus 1 all squared equals 1. So we just have to get how long these things are. Okay, well they gave us the vertice right here. It's -9 plus 2 roots of 30. See, that means from the center it went 2 roots of 30, oops, not to there, to the vertex. So the distance from the center to the vertex is 2 roots of 30. And same thing over here. There's the other vertex. That distance is 2 roots of 30. So let me go ahead and so that's the sideways one. How about I just call that A? So right here, it's 2 roots of 30 squared. The sideways axis is 2 roots of 30 squared. And now I need to try to get the up and down one, because we want this box. I want some kind of box going across there like this. I don't know how far up it is. So I need this number. That number is B. And then we already have C. I can get C right here. C is from the center to the focus point. So I already have C. Center to the focus point, -9 to -24 is 15 units. So I already know C is 15. So let's see if we can't get B out of that. So as far as focuses are concerned, I know that it's A squared minus plus B squared equals C squared. Okay, so I have the A squared. That's 2 roots of 30. I don't know the B number, so that's what this is going to find, and then C is 15. Okay, so that's 4 times 30, so this is 120 equals 225, so I'll move that over. 105 105. So b is the square root of 105. Our formula needs it squared anyway, so that's 105. How about I go ahead and do this? I already did it here. This number right here is 120. Now, I need to know the least common multiple of 120 and 105. I want to multiply everything so that the 120 and the 105 will cancel out. Well, I could just multiply them together. If I take 105 times 120, I could go ahead and multiply by 12,600. If I multiply this by 12,600, it'll cancel it. 12,600, 12,600. My guess is there's a smaller one, so I'm going to get the least common multiple again. Okay, here's the 120. How about 2 and 60? There's a prime factor. How about 2 and 30? There's another prime factor. How about 2 and 15? There's another one. And then how about 3 and 5? There's 2 more. So this is 2 to the third times 3 times 5. That multiplies up to 120. Now I'm going to do 105. How about 5 times 21 and then 3 times 7? So this is 3 times 5 times 7. The least common multiple is the biggest of all of them. Okay, that's the biggest set of 2's. So the least common multiple is 2 to the third. Okay, they both have a 3 to the first, so 3 to the first. Okay, this one has a 5 in it. They both have a single 5, and then this one has a 7. So the smallest number that 105 and 120 can both hit is 8 times 3 times 5 times 7. 840. So instead of multiplying by 12,600, see, I got a much smaller number I can deal with there. So I'm going to multiply this by 840, this by 840, and this by 840. That's the smallest number that will reduce 120 and 105 at the same time. So 840 divided by 120 is 7. Okay, so 120 will reduce that down to 7. 840 divided by 105 is 8. So 105 will reduce that down to 8. So up here, I have 7 times x plus 9 all squared minus 8 times y plus 1 all squared equals 840. All we got to do is multiply that out, and we have it. Okay, first one squared. 9x doubled, and 9 squared is 81. First term squared, y squared. 1y doubled is 2y, and the last one squared. Okay, multiply into 7. So that's 7x squared. 18 times 7 is 126. 81 times 7 is 567. Now I got to take the negative 8 across there, so it's negative 8y squared, negative 16y, negative 8 equals 840. And now just reorganize. So you do the highest powers in alphabetical order. 7x squared is the first one, minus 8y squared is the next highest power. Okay, the x alphabetically will be the next one, and then alphabetically will be the regular y. And now I need 567 minus 8 and minus 840. So let's see, 567 minus 8 minus 840 is negative 251, 281. Okay. So there's that one. And one more giving us these asymptotes. Okay, well, as usual, I'm gonna go ahead and try it out with a picture. Let's see if we can't get a picture going on this one. So they're giving us the focus points. So over 2, up, whatever that is. So 1, 2, and then up 1 plus another root of 53. And then over 2, up 1, and then down a root of 53. So that's a focus, and that's a focus. So the center is halfway between the focus points. So let's get the center first. Okay, so my center for the x's will be 2 plus 2 over 2. So that's, of course, 2. Okay, here I got 1 plus root 53 plus 1 minus root 53 over 2. Well, that adds up to 0, so it's 1 plus 1, so it's 2 over 2. So the center is at 2, 1. That's what it was right there without the plus and minus 53. See, there's the center, 2, 1. So my center is at 2, 1. I now know that it was up 53 from there, so I know that is root 53. Well, that's from the center to the focus. That's C. Okay, we got a good start. Let's go ahead and get some of our equation going. We have, okay, now this one, so this is the focus, so that means the vertex is right in here somewhere. So now it's going to be something like this. See, it's the up and down. So now it's on the y and the x part of the box. So there's going to be some kind of a box that goes in there. And see, the x part of the box is imaginary. So now the x's are negative. So I'm going to do the y one first. So how about y minus 1 all squared over something minus, and then x minus 2 all squared over something equals 1. Now we don't know what those somethings are yet. Okay, let's take a look at this slope of this asymptote. Remember, the asymptote goes right through here. Goes through the corners of that box. Okay, the slope means we rise 2 and run 7. So from the center, it went up 2 and over 7 to right there. Okay, well, that's the up and over of these vertices. If I know that point, that's the same as where the vertex was, and it's up 2 from the center. So up 2 is where the vertex is. So I know that distance right there is 2. And then I know this distance right here is 7. So I know this distance right there is 7. That's what up 2 over 7 does. It gives me the height and the width of the box. Okay, well, that's what this needs. This y number right here, it needs the height of that box. Well, it was up 2. And the x needs the width of that box. Well, it was 7. And there's our equation. So 2 squared is 4. 7 squared is 49. Okay, a common denominator between 4 and 49 is, it's going to be 4 times 49, 196. So I'm going to multiply this side by 196, that piece by 196, and that piece by 196. 4 goes into 196 49 times. 49 goes to 196 4 times. So I've got 49 y minus 1 all squared minus 4 x minus 2 all squared equals 196. And let's square it out. So I've got 49 y squared, double the middle, 2y, square the back. Minus 4, the first piece squared, negative 2x doubled is 4x, and 2 times 2 is 4. Multiplying the 49. So I have 49x squared minus 98, oops, that's a y, 49y squared minus 98y plus 49, multiplying the negative 4. Negative 4x squared plus 16x minus 16 is 196. And now regroup. So alphabetically highest power. So here's the highest power alphabetically is the x squared, so that's that one. Then comes the y squared, 49y squared. Then comes the x, so plus 16x. Then comes the y, minus 98y. I've got 49 minus 16 minus 196. 49 minus 16 minus 196. Negative 163. And there we have it. So that asymptote, really all we needed was the slope. That was the rise and the run from the center. Now notice all of these, one of the first things I found was the center, which really got everything going. Okay, concentrate, give these a try.